Good morning everyone. Now I am going to discuss some definitions, that is the divergent of a vector and solenoidal. It is very important, and I would like to discuss a problem how we can find out the solenoidal, what is the condition of the solenoidal. Divergence of a vector means divergent of a vector let f vector be a continuously differentiable vector point function, then the div f or del dot f vector can be defined by I dot dou f bar by dou x plus j dot dou f bar by dou y plus k dot dou f bar by dou z. It is called as the divergent of a vector point function. It is denoted by div dot f bar or del dot f bar. Okay. Here f be a continuously differentiable vector point function. In this, we can define the divergent of a vector f bar is I dot dou f bar by dou x plus j dot dou f bar by dou y plus k dot dou f bar by dou z. That is nothing but the differential operator in the vectors, that is del, is in between of del operator and f vector is dot product is there. Del is a one vector operator differential. F vector is also a some vector defined in the particular region. Then dot product of in between of operator del and f vector is said to be the I dot dou f bar by dou x plus j dot dou f bar by dou y plus k dot dou f bar by dou z. It is called as the divergent of a vector f bar, and it is denoted by div dot f bar or simply div f bar, and another one is del dot f bar. Okay. The solenoidal of vector means solenoidal of a vector f bar, that is nothing but if f vector is a solenoidal, if f vector is said to be solenoidal, then div f bar or del dot f bar must be equal to 0. If the divergent of any continuously differentiable vector point function is 0, then the continuous differentiable vector function f bar is said to be the solenoidal. Okay. And in the same case, curl of a vector, curl means in this also f vector is said to be the continuously differentiable vector point function, and it is defined as I cross dou f bar by dou x plus j cross dou f bar by dou y plus k cross dou f bar by dou z is said to be the curl of f vector, and it is denoted by curl f vector, that is equal to del cross f vector, that is simply denoted by I, j, k, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3, where f vector is equal to f1i plus f2j plus f3k. Here f1, f2, f3 are the functions of x, y, z variables. Okay. Here notation is del cross f, that is nothing but del is a operator, f is also a vector. Both are vectors. In between of two vectors, the cross product is there, then that is called as the curl F vector. That is nothing but in the 3 by 3 matrix form, those two are vectors. So the first row is vector components, that is I, J, K. Second row is del operators, that is the partial derivatives. The third one is functions of F1, F2, F3 in the F vector. Okay. Here irrotational. Here irrotational. Irrotational means if or let F vector is said to be irrotational if curl F bar equal to 0. That is nothing but if del cross F bar is equal to 0, then F vector is said to be the irrotational. If div F bar is equal to 0, then F bar is said to be solenoidal. In the cross product, when the curl F bar is equal to 0, then the vector differentiable function, that is F bar, is irrotational. In the irrotational condition, if we can find out the conservative force of any field, that is nothing but conservative force means the relation is curl F vector. If the curl F vector is equal to 0, then F vector is a conservative force, and in this force case, then there exists a scalar point function pi such that F vector is equal to del pi. That is nothing but grad pi. It is the grad pi. Del pi is nothing but grad pi. When curl F bar is equal to 0 means curl grad pi is equal to 0. If curl grad pi is equal to 0, then pi is a potential. Okay, this pi function is called as a potential function in particular region. Then grad pi is a conservative force. Then in a field, curl F is a conservative force. These are one to another related. If you don't forget and don't bother about the, when the terms will come, irrotational, rational, conservative force and potential. The conservative force means curl F bar equal to 0, then the conservative force is relating with the scalar function pi, then function is called as the potential function. Okay, these are one to another interlinked together. Okay, the main thing is solenoidal means div F equal to 0, irrotational means curl F equal to 0. Now I am taking one problem and how we can find out the solenoidal and irrotational. The problem is prove that F vector equal to yzi plus zxj plus yxk is irrotational. Irrotational. The second one is 3y power 4 z square I plus z cube x square j minus 3x square y square k. Second one is x plus 3y I plus y minus 2z j plus x minus 2z k is solenoidal. This is solenoidal. The first problem solution. Prove that F vector is irrotational. F vector is irrotational means to show that curl F vector is equal to 0. That is nothing but to find out del cross F vector, that is equal to I, J, K, dou by dou x, dou by dou y, dou by dou z. I component is yz, j is zx, k is yx. Then find out the determinant I into dou by dou y of yx minus dou by dou z of zx minus j dou by dou x of yx minus dou by dou z of yz plus k dou by dou x of zx minus dou by dou y of yz, that is equal to del cross F vector is equal to I into y derivative is 1, then remaining term is x, z derivative is 1, the remaining term is x, minus j into x derivative is 1, remaining term y, z derivative is 1, remaining term is y, plus k into x derivative is 1, the remaining is z. Here y derivative is z, 1, the remaining is z. So x minus x equal to 0i minus 0j plus 0k, that is equal to 0. Here del cross F vector is equal to 0. Therefore F vector is irrotational. It is the irrotational. This is the solution of finding of irrotational. Next, to find out the solenoidal. Solenoidal means, second one, solution. Let F vector is equal to 3y power 4 z square I plus z cube x square j minus 3x square y square k. To show that F vector is solenoidal means div F vector is equal to 0. Div F vector equal to del dot F vector, that is equal to I dot dou F bar by dou x plus j dot dou f bar by dou y plus k dot dou f bar by dou z must be equal to 0. Here find out the dou f vector by dou x. It is equal to, in the first term no x variable, in the second term x variable is there, that is z cube is treating as a constant, x square derivative is 2xj minus x square derivative is 2x, 2 3s are 6 x y square k, that is dou f bar by dou x. Dou f bar by dou y is equal to, with respect to y means its y power 4 derivative is 4y cube, 4 3s are 12, 12y cube z square I, in the second term no y term, minus y square derivative is 2y, 2 3s are 6 x square y k. Dou f bar by dou z is equal to, in the first term z is there, z square derivative is 2z, 2 3s are 6 y power 4 z I. In the second one, z cube derivative is 3z square x square j. In the third one, no z term, so it is the 0. Then div f bar is equal to del dot f bar equal to I dot dou f bar by dou x plus j dot dou f bar by dou y plus k dot dou f bar by dou z. In the f bar, dou f bar by dou x, no I and no I term, that is I dot dou f bar means 2z cube xj minus 6xy square k plus j dot 12y cube z square I minus 6x square yk plus k dot 6y power 4 zi plus 3z square x square z. We know that I dot I equal to j dot j equal to k dot k equal to 1 and I dot j equal to j dot k equal to k dot I equal to 0. By using this relation, in this I dot j is 0, I dot k is 0, j dot I is 0, j dot k is 0, k dot I is 0, k dot j is 0. Therefore, div f bar is equal to del dot f bar equal to 0. Therefore, f vector equal to 3y power 4 z square I plus z cube x square j minus 3x square y square k is solenoidal. The second one is it is the one type. The second type is same. We can find out same div f bar. Let f bar equal to x plus 3y I plus y minus 2zj plus x minus 2z k. We can prove that it is a solenoidal. In the second one, first problem also solenoidal. But in that case, we can find out the individual partial derivatives of the f vector. Here, to prove that f bar is solenoidal, that is nothing but del dot f bar is equal to 0. Del means I dou by dou x plus j dou by dou y plus k dou by dou z dot f vector is x plus 3y into I plus y minus 2zj plus x minus 2zk. Directly we can take the operator del and f vector. Then dot product in between of two vectors means we know that the relation is I dot I is equal to j dot j equal to k dot k equal to 1. I dot j is equal to j dot k equal to k dot I is equal to 0. By using this relation, we can dot product of in between of two vectors, then it is equal to dou by dou x of I component in the second vector, that is x plus 3y plus dou by dou y of y minus 2z plus dou by dou z of x minus 2z. Okay, here x derivative means here x term is 1, the second one is 0, 1 plus 0 plus dou by dou y of first one is 1, the second one is 0. Why? Because in the second term no y variable. The third one x is 0, 2z means that is minus 2. It is equal to 2 minus 2 is equal to 0. Why? Because 1 plus 1 is 2, 2 minus 2 is 0. Therefore, del dot f vector equal to 0. Therefore, f vector is solenoidal. That is x plus 3yi plus y minus 2zj plus x minus 2zk is solenoidal. It is the another method of solenoidal we can find. It is easy to find out the dot product of in between of operator and vector. Then we can directly differentiate of I component with respect to x, z component with respect to y, k component with respect to z, and simplify. After the simplification, if we get the product is 0, then that is nothing but the given vector point function is solenoidal. Okay, this is the way how we can find out the irrotational and solenoidal. Okay, if you like this video, you can subscribe my channel and you can share to your friends, and if you have any doubts, you ask me. Okay, thank you.